Let's talk a little bit about the physical structure of the hair. There are three major components of the hair: the cuticle layer, the cortex, and the medulla. The cortex makes up 90% of the hair's total weight. This is where the physical and chemical actions take place during chemical processes. And it's the structure of the cortex that we address when we speak of bonds. The chemical composition of the hair consists almost entirely of a protein called keratin. Keratin is made up of about 18 amino acids bonded together to form a polypeptide chain. These chains intertwine around each other in a helical shape to form the main structure of the hair. Chemical bonds hold them together. This is what will determine the hair's texture and shape. Hair characteristics are determined by the type, amount, and distribution of these bonds. To change the style or texture of the hair, we rearrange or shift the bonds between them. There are three types of bonds that play a role in these shifts: the disulfide bond, the ionic or salt bond, and the hydrogen bond. The disulfide bond is a strong, permanent chemical bond between two sulfur atoms in the amino acid cysteine. Proteins in the cysteine cross-link with disulfide bonds in a covalent process. The disulfide bond is the strongest bond in the hair, but it's the fewest. Shifting these bonds influences the hair's curliness and can alter the shape permanently. These bonds are broken only by a chemical reaction. The ionic or salt bonds are relatively strong. They account for about 1/3 of the hair's strength. They're referred to as ionic bonds because the bonds between protein chains is due to the attraction of the unlike electric charges. The salt bond is broken by water. Breaking and rejoining these bonds will give the hair a temporary set. The hydrogen bonds, although relatively weak, are plentiful in the hair. They provide about 1/3 of the hair strength when the hair is dry. Changes to these bonds are temporary and are easily broken by water or heat styling.